Now we have decided the module using velocity factor, that is F effective is equal to K km ft divided by kf. K is a application factor, km is a load distribution factor, and ft is the tangential load, right? And kv is the velocity factor, and this kv is equal to, for a spur gear, we have taken this 6 divided by 6 plus v. Now, for how you decide this application factor, this service factor selection is based on input and output device. In our case, input device or a prime mover is electric motor, and output device or driven member is agitator. So, uh, from R.B. Patil book, that is Design of Machine Element by R.B. Patil, this agitator falls under the category of uniform load. Now we have to decide working, that is a loading condition of agitator. Here we will assume that gearbox for a agitator is working for 12 hours a day. So prime mover is electric motor, driven machinery is agitator, duration of a service is 12 hours per day. So from this we can select load distribution factor considering face width of gear is up to 50 mm and less rigid mounting with less accurate gears required. Let us consider. So in this case, km is equal to 1.6. Km is equal to 1.6 and K is equal to 1. Okay. Now, after deciding this, K is equal to 1 and Km equal to 1.6. So, K equal to 1 and Km equal to 1.6. That is service factor and load distribution factor. Okay. Now, after finding out module by velocity factor, we have to check whether this design is safe using Buckingham's equation for dynamic load. In such a case, F effective is equal to Fd plus Ft max. It is equal to Fd plus Fd max, where where Fd is dynamic load by Buckingham's equation. Ft max, maximum tangential load, and that Ft max is K km Ft. K equal to 1 and km equal to 1.6. So Fd, this is a Buckingham's equation for a dynamic load, and Fd is equal to 21V in bracket Bc plus Ft max divided by 21V plus under square root Bc plus Ft max. Then here you will get the Fd, then F effective is equal to Fd plus Ft max, and then you can find out factor of safety, and you will come to know whether design is safe or not. So once design is safe under these conditions, then we'll get that module as correct module, and then we'll find out dimensions of the gear. Okay, so after calculation, these dimensions are given, that total gear ratio is 1440 divided by 150 is equal to 9.6. G1, that is gear ratio in stage 1, it is 3.6. Gear ratio in stage 2, it is 2.667. For stage 1, ZP equal to 20 ZG, that is 72, and for stage 2 ZP equal to 18 ZG is equal to 48. Now for a pinion, material is C45, for a gear it is C35, Mn75. Beam strength calculated is 758.3 m square, and wear strength in terms of module is 318.96 m square Newton. This m for a module, because you have to find the module. Now when you will compare between beam strength and wear strength, SW is less than SB. That means wear strength or pitting failure will be the design criteria, right? So design will be based on wear strength. Then tangential load is 35788.73 divided by m. kV is 6 divided by 6 plus v. Factor of safety selected is equal to 1.5, and F effective is equal to K km Ft divided by kV. So after this, whatever module will calculate, that module is 6 mm, addendum HA equal to 6 mm, because addendum is equal to what? 1 into standard module, or 1 times the standard module. So addendum will be equal to module, that is 6 mm. Dedendum is 1.2 into m, and that is 1.2 m. So dedendum is 1.2 into m. So HF is equal to 7.2 mm. Actually, it is 1.25 m. So it will be 7.5 mm like that. Clearance is 1.2 mm. Fillet radius 2.4 mm, and tooth width T is equal to 9.4248 mm. So these are the dimensions for spur gear. Okay. So first we have designed stage 2 actually. Whenever we reduce the speed, first we, that means in the first stage speed reduction is from higher to lower. So spur gears are not feasible over there because they cannot run at high speed. That efficiency is less as compared to helical gear. So for a first stage, we will use a helical gear, and for a second stage, we are going to use a spur gear. So this is the design for spur gear, and these are all the dimensions of spur gear. Okay. In the next session, we will see design of a helical gear. Actually, it is stage 1, but first we have design stage 2, that is the design of a spur gear.